Hello everyone, welcome to my classroom. In previous session we have seen two words, latch and flip-flop. We know that latch is used to design asynchronous sequential circuit. Flip-flop is used to design synchronous sequential circuit. Generally, latch and flip-flop, these two are nothing but memory elements or storage elements. So, latch and flip-flop are used to store the data. In today's session, we are going to discuss about latches in combinational logic circuits. Before going to the topic latches, let's see what is a storage element. Storage element or memory element, both are same. These two are used to store the data. Here the data is nothing but output data. Observe, a storage element in a digital circuit can maintain a binary state. So binary state, I'll explain this term, that is nothing but related to output. So it can maintain binary state as long as the power is supplied to the circuit. So it maintains output values as long as power is delivered to the circuit. Next point, it maintains the state until it is directed by an external input. Listen carefully. It maintains the state, that is nothing but it holds the state until an external input is applied to the circuit. If second input is applied to the circuit, then only the output is going to change. That is nothing but switching of states. So here binary state, switching of state, these two words are different. So I'll explain these two by using a topic bistable circuit. In previous session we have seen this word bistable circuit. Observe, bistable. So two stable states. Bistable circuit is nothing but a circuit having two stable states. Observe, two stable states. Consider this is the circuit, my input and output values. So I have applied inputs like 0, 1, 0 and so on. So consider these are my inputs to the circuit. So inputs are processed by the circuit and outputs are obtained like 1, 1, 0 and so on. Consider. So inputs and outputs. So I am taking all these outputs as first state. Listen carefully. I am considering all these output values as first state. So these output values are stored in latch or flip-flop into a storage element. This state is going to be changed only when another input values are applied to the circuit. Listen, this state is going to be changed only when another input value is applied to the circuit. Consider my input is 1, 1, 1, 0 and so on. This is my second input values. So if these values are applied to this circuit, then the outputs are going to be changed and my new outputs are considered 0, 1, 0, 1 and so on. These are my new values. Observe here, these are my new values. Consider this is my second state. So this is my first state, this is my second state. First state is going to be changed only when second inputs are applied to the circuit. Second state is going to be changed only when third inputs are applied to the circuit. So in general, latches and flip-flops, these two circuits use bistable circuits. Observe carefully. In latches and flip-flops, we are going to consider bistable circuits. This is about state change, that is nothing but switching of states. Next, we will see what is the difference between latch and flip-flop. We know that latches and flip-flops, these two are memory elements or storage elements. The main difference between latch and flip-flop is nothing but a clock pulse. Observe, the main difference between latches and flip-flop is nothing but a clock pulse. Flip-flops contain clock pulse, whereas latches do not contain any clock pulse. So these two are related. Latches are basic building blocks of flip-flops. If you add any clock pulse to latch, then it becomes flip-flop. If clock pulse is removed from flip-flop, then it becomes latch. Next, observe latches. Latches are the basic storage elements we know. Latches are useful for designing for asynchronous sequential circuits. Okay. Latches are level sensitive and level triggered device. Observe these two words carefully. Level sensitive and level triggered devices. So sensitive or trigger. So these two words are used to make circuit active, because observe here two circuits, first circuit, second circuit. So this circuit is going to be active only when high level signal is applied as input. Listen carefully. This circuit is going to be active only when high level is applied to the circuit. The second circuit is going to be active only when low level is applied to the input. So that is nothing but level sensitive or level triggering means. So triggering means nothing but making the circuit active. This is about level triggering in latches. Next, types of latches. There are mainly two types of latches. One is RS, next one is T. In this session, I am going to discuss only about RS latch. Observe carefully. RS latch, that is nothing but reset set. So if reset pin is active, if R is active, then the output becomes 0. That is nothing but output is resetted. If S is active, then the output is set to 1. Listen carefully. If R is active, then output becomes 0. If S is active, then output becomes 1. So observe these two words. And next, RS or SR both are same. RS latch is a circuit having two cross-coupled NAND gates or two cross-coupled NAND gates. Observe, cross-coupled. So this is nothing but cross-coupling. Output is given as input to this one. This output is given as input to the first one. So this is called as cross-coupling. So two cross-coupled NOR gates, two cross-coupled NAND gates. So this is one way of representing RS latch. This is second way of representing RS latch. In this session, I am taking this circuit. I am doing my operation. Observe here. RS latch using NOR gates. I have considered two NOR gates. So first NOR gate, second NOR gate. So both are NOR gates. So to operate this, I want to know the truth table of NOR gate. So this is truth table I have considered here. A, B. We know output becomes 1 only when A, B both becomes 0. This is NOR gate. So if you know this one, it is easy to operate this circuit. And next, observe R pin, S pin. So these two are input pins. Q, Q bar. These two are output pins. So here you have to concentrate more. So this is very, very important. Input values, output values. So here I am taking this as QP and QP bar. So that is nothing but present output. So observe present output. So this is nothing but complement of output. So in some cases, you will consider this as present state, this as next state. That is very, very wrong. These two are present state outputs. This is complement to this one. And if you get next value, so if you get another value by changing the input, then that values are considered as next state. So this is present state in output. This is present state complement value of output. So next values obtained by changing the input values, then that values are considered as next state values. So here no need to consider next state, only think about present state. So possible RS combinations are S combinations, two inputs, either 0 0, 0 1, 1 0, 1 1. Total 4 combinations are possible. So I need to derive outputs for these 4 combinations. So see here, QP is output, QP bar is complement of output. So these two are present state only, but not next state. This is the operation procedure of SR latch. So before going to start the procedure, I just want to remind you one point, that is nothing but latch acts as a memory element. We have to prove that point here. So consider either 0, 1 or 1, 0 conditions. So I am not at all considering 0, 0 condition as input, because 0, 0 my input means we are not giving any input to the circuit. 0, 0 means we are not at all giving any input to the circuit. So I am taking first 0, 1 or 1, 0. Consider 0, 1 condition. S is 0, R is 1. So observe this truth table very carefully. We know one input, we don't know second input. Here also one input we know, don't know the second input. So one input is 0. If the second input is 0, then output becomes 1. If the second is 1, output becomes 0. So there is change in the output values. So don't consider this one. So come here. We know first input, that is nothing but 1. We know one input. If the second input is 0, if it is 0, output is 0. If it is 1, output is 0. So in this condition, whatever be the second input, listen carefully, in this condition, whatever be the second input, the output becomes 0. So I am taking this condition. So whatever be the second input may be, output is 0. So this output I am giving to this circuit. So 0, 0. 0, 0 are my inputs to the second NOR gate. So 0, 0 are my inputs. So my output is 1. So this is the way you need to operate the latch. So observe, for S0 R1 condition, output is 0. Complement of output is 1. So both are complement of each other. Okay. So as I said in previous slide, if reset button is active, reset pin is active, if reset is active, then the circuit resets the output. So this is my output, this is complement. Consider this output. It resets the output. So output is 0. Reset operation is success here. So I performed one operation. Next, here I am going to check my circuit, either it is going to work as a latch or not. So for this condition, I am taking my inputs. Observe. I am taking my inputs as 0, 0. That is nothing but I am erasing my inputs. I am erasing my inputs. I am not at all giving inputs to the circuit. So observe. Here input is not changed. Here input is changed. So consider the output related to not changed condition. Consider the output related to unchanged condition. So that is nothing but 1. So this 1 I am giving to this circuit. So 0, 1. Observe, 0, 1. It results 0 as output. This is my new output. So this output I am giving to this circuit. This output I am giving to this circuit. So 0, 0 are my inputs. 0, 0. My new output is 1. So in 0, 0 condition, my new outputs are 0, 1. Observe, Q is 0, Q bar is 1. If you observe this carefully, in first condition, my outputs are 0, 1. In this condition, my outputs are again 0, 1. So I am erasing my inputs. I am not at all giving any input here, but my outputs are 0, 1. It means, so these values are stored in the latch. Listen carefully. These values are stored in the latch. Okay, so 0 0 condition acts as a memory element. Okay, proved here. We have to prove in this point. So consider like this. Okay, now again I am taking inputs, that is nothing but S1 R0. S is 1, R is 0. Again listen carefully, this is very important for latches and flip-flops. So operation is the same, S1 R0. In this condition, for different values of input, output is different, so don't consider this one. In this condition, for different values of input, whatever it may be, either 0 or 1, either 0 or 1, we know one input, so either 0 or 1 will get 0. So whatever be the input may be, will get 0 here. This 0 I am giving to this circuit. Observe. So 0 0 0 0 results 1. So S1 R0 condition, S1 R0 condition, Q is 1, Q bar is 0. So set is activated, set is activated. So output is set to 1. Set is 1 means output is set to 1. So this is complement. Okay. So this condition, S1 R0 condition is used to set the output to 1. So satisfied here. Next we need to check 0 0 condition. 0 0 condition, whether it is going to store the data or not. Observe here, I am erasing the data here. I am taking 0. So here previous data is 0. Now data is 0. So this is not at all changed. So consider output related to this one. So 1. I am giving this output here. 1 0. Observe 1 0 are my inputs. 1 0. 1 0 results 0. This is my new output. 0 I am giving here. 0 0. Observe 0 0 results 0 0 results 1. My new output again. So listen. In first condition my outputs are 1 0. In my second condition my outputs are again 1 0. So here I have given input 1 0. Again I am erasing my inputs. So I am erasing my inputs. So after erasing inputs, outputs are same. That is nothing but again this circuit acts as a memory element. So it is stored the previous data. Here the previous circuit is S1 R0 condition. In this case the previous inputs are S0 R1 condition. If you observe these two cases, here 0 1 output is stored. Listen, 0 1 output is stored here. Again 1 0 output is stored here. Finally S0 R0 condition. So it is said to be a memory condition. Listen carefully. S0 R0 condition is nothing but memory or storage condition, because in this condition it is used to store the previous data. Here the previous data is 1 0. Here the previous data is 0 1. So this condition stores the previous data. Okay. Till now we have completed 0 0 condition, 0 1 condition, 1 0 condition. Next 1 1 condition. This is very important in SR latch. So observe 1 1 condition. I am taking two inputs. Okay. S1 R1. Listen carefully. S1 R1. So one input is 1. We don't know the second input. One input is 1. We don't know the second input. So observe this. One input is 1. We don't know the second input. Whatever be the second input may be, whatever be the second input may be, output is 0. Listen carefully. So if it is 0, it results 0. If it is 1, it results 0. So whatever be the second input may be, it results 0. Similarly here, whatever be the second input may be, it results 0. My inputs are 1, 1. My outputs are 0, 0. Observe, this is complement of this one. Is it possible both are same? 0, 0. It is not possible. So that this is a wrong condition. This is the first drawback in S1 R1 condition. So next I am taking memory erasing condition. I am erasing the memory. So consider. So erase this memory. I am placing 0 here. Erase this memory. I am placing 0 here. Observe carefully. So this is changed to 0. This is changed to 0. So these two values are changed. Observe, these two values are changed. So I don't know either I want to consider this one or this one. I don't know. So either to consider this one or this one because these two are changed. So first I am taking one condition. So one condition. So I am considering this Q and I am applying here. Listen, I am considering this here and applying here. So that is nothing but 0, 0, 0, 0, 0. Output is 1. So again I am applying 1 here. 0, 1. It results 0. In this case, I am considering output related to this Q value. So we can consider this also. First I am considering this Q value and my outputs are 0, 1. Observe, my outputs are 0, 1. Here Q value I am considering as input and my outputs are 0, 1. Okay. Next, so we can also consider this one. So I am going to consider that one here. So I am considering this point. So again I will draw. Okay, 1, 1 condition, outputs are 0, 0. In my first condition, I have considered this value and my outputs are 0, 1. Next, in this case, I am going to consider this value. So I am taking this and I am applying here. So in 0, 0 condition. In 0, 0 condition, both values are changed. So in first case, I have considered this one and my outputs are 0, 1. In second case, I am considering this one and 0, 0, 0, 0 results 1, 1, 0 results 0. My outputs are 1, 0. If you observe all these carefully, if I consider this value, then outputs are 0, 1. If I consider this value, my outputs are 1, 0. For this same condition, already it is a wrong condition. Again, two different conditions. So, S1 R1 is not used condition in SR latch. Observe, for the same condition, we have two different outputs in this case. So that we are not at all using this condition. Finally, truth table for SR latch. Observe this truth table. So I have drawn all these values by considering the operation output values. Listen. First I am taking 0, 1 condition, that is nothing but reset condition. So this is output, this is complement of output. So reset is active here. Output is 0. So output is resetted and complement is 1. Okay, satisfied. 1, 0 condition. Output is setted to 1. Observe, output is setted to 1 and complement is 0. Okay, so see here 0, 1 condition, state is reset state. 1, 0 condition, it is set state. Next, 0, 0 condition. Listen, 0, 0 condition. We know 0, 0 condition acts as a memory or storage condition. So observe, whatever be the QP value may be, so it is going to get the same value. So previous value is stored here. So if you use 0 0 after 0 1, so if you use 0 0 after 0 1, it results same values, that is nothing but QP value, QP dash value, that is nothing but QP and QP bar. So I am taking answers like this. So I don't mention 0 1 or 1 0. So it is memory state. So it is also called as no change condition. And we know 1 1 state. So this is having many problems. So this is invalid or forbidden or not used state. So this is about truth table of SR latch. So listen this video once again if you don't understand. Next, SR latch using NAND gates. So this is same as SR latch using NOR gates. So try to solve this on your own. Apply first 0 1 condition and observe the output values. Apply 1 0 condition, output the observed values. Next 0 0 condition and 1 1 condition. So this is truth table for RS latch. So if you observe this carefully, if S is 0, if S is 0, then output becomes 1. So which is complement to this one. If S is 0, output becomes 1 here. So complement to this latch. So NAND and NOR. So these two circuits give two different answers. So you have to pay attention here. If you use NAND gate, outputs are different. If you use NOR gates, outputs are different. So consider NOR gates for every exam and try this one on your own. In next class, I will be discussing about the latch. Thank you.